Good morning, and thank you for joining our special webinar series from SPEC Innovations, How to MBSE. We're going through the entire system lifecycle in this series. Last time we showed you how to write requirements, and today we're going to show you how to develop and simulate models with no coding experience required. My name is Elizabeth Steiner, and I will be the moderator for today's webinar. First, let's go over some quick housekeeping. During the presentation, feel free to send us questions and we will get them answered in the question and answer part of the webinar. You can also interact with us on LinkedIn through the NSLate user group or through Twitter using the handle @NSLate. The webinar is being recorded and we will make it available to you after the live presentation, so be sure to keep an eye out for it in your inbox. Now I would like to introduce you to our presenter, Dr. Steve Dam. Dr. Dam is the president and founder of SPEC Innovations, as well as one of our DODAF training instructors. He has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. He has also received an Expert Systems Engineering Professional certification from INCOSE. He currently is applying systems engineering techniques to various DoD, DOE, and commercial projects. Feel free to send Dr. Dam any questions throughout this webinar using the questions panel on the right. And now I'll hand over the controls to Dr. Dam and we will get started.
Thanks, Elizabeth. So when we did last time, we started out with the V diagram, and again, you know, everybody knows that the V is just one way to view the life cycle, and of course, the tool supports all phases of all different life cycle models. So for this one, we're going to focus on simulation. So where does it fit into that life cycle? Well, particularly it's part of functional analysis. It's a key part of what we do in functional analysis in terms of making sure the models actually work. Kind of an important thing. And usually at that point, that early part, it's just a simple thing you're doing in terms of checking the initial information. Now you can start using it for predictive analysis as well. But of course, until you get into verification is probably when you're going to use the simulators as well and particularly you're going to be able to calibrate it to some experimental data. Usually in verification, you're at that kind of lower level, you've done your unit testing, things like that. You're starting to bubble that up, and so you can see what those performance things as you calibrate your model. And then in validation, of course, you can go ahead and you hopefully be at an operational level, and you can understand and make sure that the model becomes even more predictive. Particularly since one of the things we're trying to do in modeling simulation with the digital engineering today is to make sure that we can come back to that model and reuse it. And so that's one of the big things they're trying to do, is have a reuse of the models rather than start from scratch every time. So another thing, of course, is for risk analysis. Simulation is very useful for that purpose, particularly the Monte Carlo, to give you an idea of your variance and help you understand it there. And also, of course, for operations analysis, we highly recommend Sepatra. It has specific metrics to help you do that kind of analysis, and it is using the discrete event and Monte Carlo simulators in InnoSlate as well. So from last time, we had a few slides on simulation, even though that wasn't the primary topic. We were talking about requirements. So I'll just kind of refresh your memory, or if you're new to the webinar, this will be help you get some context that maybe some other people who had attended have. So for requirements, you know, again, we want to make sure that model is a working model that actually reflects some sense of reality. Again, all models are wrong, some models are useful, right? And so if we can execute that, we can start identifying timing and resources and other potential issues you might have, or other constraints you might have. If you can couple it to the physical model as well, and we're going to be talking about that a little bit more, and look at that. You're going to do cost analysis. So again, we're going to talk about more of that today. The same thing on the risk, again, capturing your risk analysis is part of that. The simulation part, again, for performance requirements, again, the Sepatra is a really good way to start looking at that whole available time window. Can the procedure meet that available time window? If it can't, then I might have a lot of failures, and if it can be to a point where it can cause serious impact to your system or to people, more important part of the system. So again, that human errors helps you find the problems using Sapatra for that purpose. And anyway, so let's go on and do the next thing. So what are we going to talk about today? So I want to talk more about, get a little deeper into the elements of functional modeling. What do we do with that? How does that work? And then how the physical models constrain the functional model. That's an important concept. We think that it's important to have the two working together. And of course, costing elements. So if you want to do cost analysis, I'll show you how to do that. And then we'll give you a little brief introduction to scripting. If you're not familiar with it, you don't have to be a high-end programmer to do scripting. Most people have done a little bit of that, or most of us have taken some coding classes, at least in school. So you have a little bit of background in it. Maybe it wasn't your favorite thing in the world, but it's pretty simple to use the scripting language that we have. It's simply JavaScript. And so there are books and books on JavaScript and a lot of help in using JavaScript. And then link to other simulation tools. So you start getting more advanced and you want to start tying in other things, particularly the geospatial physical constraints from a tool like SDK. We have that capability as well. And I'll just summarize that kind of at a high level. So that alone could be a whole webinar by itself. Okay, so the action diagram is our main diagram for functionality or behavior. Again, it depends on how you want to look at it. It's very expressive. One of the things that's nice, this is from the lifecycle modeling language. Instead of having constructs, we have a special type of action and for those decision points. And so you see the loop and the sync point here, for example. And so I'll explain what some of those mean, or all those mean here in a minute. But so you can see, but you see that that's what they are. There's a loop and a sync. I know what that is. I don't have to guess. So that's very helpful. Also, we have explicitly the resources being shown in the model as well. So again, that's a unique kind of feature. That's actually an extension of LML. That wasn't a requirement in LML, but we thought that was a good thing to do to add that ability. Resource modeling was in LML, but the actual visualization of it wasn't necessarily part of that when that was originally done. And again, I'm going to go through all those in more detail here in a minute. So let's see. So if you start up an action diagram, you create an action diagram, and it's fairly easy to do. There's a simple menu on the left. Not a lot of things to have to pick from. Okay. And so the top one's a simple action for a serial action. So that's what that really is. It basically means that I'm going to go from one action to another, and that happens automatically. So you see that in the S.1.6.2 and the S.1.6.3. Okay, so it goes from one to the other, and as soon as the dig soil for analysis finishes, it will execute the conduct preliminary analysis. Okay. So again, that's a serial process. Parallel, you also see that those are in a parallel branch and 3 branches there, and that's used now as a simplification of the sync point. The sync point purpose is a general synchronization of parallel branches. What happens with a sync point is it allows you to have like a timeout. So in other words, let's say I can't complete all 3 of them within a certain time frame. It will automatically pop you out of that. And so it's sort of like if you want to think about it as a non-exclusive OR, I sometimes call the sync point that. So that's a kind of interesting one. And of course, the OR, and we'll show you some OR examples a little bit later. And then last but not least is the loop. So it's in a big loop, this execute search pattern. And then until the search pattern is completed, then it exits the loop and goes to the end. And so it's a fairly easy thing to read. I think you can kind of understand the basic things. The palette is simply drag and drop. So it's very easy. All you do is drag something onto a line, it goes green, and it's right there. So I'm going to actually demo that for you, so you'll see more of that here in a little bit. The branch asset is a physical element and it's an element, and you can associate that with any parallel branch. And what that does is it automatically allocates the actions to those assets for you. So the tool does a lot of that bookkeeping, tracking, traceability that you're looking for automatically. IOs, of course, are the parallelograms. They can be either a trigger or an optional, and an optional means that it doesn't have to wait for that IO to execute. Okay, so it's very simple. And then last but not least, here is the resource. So resources can be consumed, they can be produced, or they can be seized. And so you have those different operations that happen, and and a resource is a subclass of assets. So it's a physical kind of thing. So it represents things, and it has some other interesting properties. We'll see in a minute. Okay, so the basic action is here, and the loop construct, input output entity, and resource entity. So you can see I've gone through all those verbally. I just wanted to make sure you see them again and see what they specifically mean. Hopefully it's fairly easy to read and easy to understand and easy to explain, more importantly, to the other stakeholders, because as systems engineers, we have to actually communicate to a lot of people. So this is meant to be a very communicative, easy to understand. Nobody has to know the code book for what the symbology means. It's pretty simple. Okay, so the functional model being constrained by the physical model. Okay, so that's, I mentioned that you have the assets are on a branch. And so example above here is there's a payload branch, and it's going to connect to another branch, which is another actor in it. So in this, it's mission operations. You can't see it in the picture, but that's what it is. And so when I send this 911 warning message down the pipe, okay, I'm sending it down, I'm transferring it down that conduit. Now the conduit has capacity and latency associated with it. Okay, so that's how we help create that constraint, right? Because the capacity, the IO has a size. So I go through and I look at the sizes, and if the pipe capacity, it's triangular distribution, and of course you can put distributions in anywhere there's a number field in the slate. And again, that's oftentimes because you don't know the exact number, or there's an uncertainty in it that you want to capture. And this particular way you read that is a triangular distribution is, okay, so it goes from a 1 to 3 is the maximum, and 2 sort of that middle point. So that midpoint. So that's what that distribution looks like. And so you see that's kilobytes. And so now the size is 30 kilobytes. So if the size is that large, then it's going to slow that down a little bit, and you'll see a delay in the along with a delay due to the latency. So you can see that if you're starting to look at the short time information and looking at that and seeing how it's delayed. So anyway, that's how you do it. So it's very simple, but it is something that this is, again, that give that physical and functional model. The conduit's going to connect those two assets. It's going to connect the FireSat system, which includes the payload, right? And in fact, I would probably change that to say payload, particularly, and then to mission operations. So again, hopefully that's helpful. Easy to see how you can connect the two and work with them. So I'm sure there would be questions at some point. So hopefully we'll have a chance to get to some of those when we do the live demo. Okay, so another thing was cost. How do we add cost into it? Well, anything can incur a cost. So particularly the actions, when the actions incur a cost, in this case, we have this deploy into parking orbit. It incurs a cost called deployment cost. If I go to my work breakdown structure, which is my set of cost elements, I can see it here. It's in there. It's a little small to see, but it's available for it to use that data to factor that into the cost estimation. So as you run the simulator, what it does is it just starts accumulating those costs. So these are dynamic costs, and they can be fixed or they can be per hour. So you can include like people costs, things like that with it as well. So there's assets can be had cost to it too. So there's a lot of ways to use this in the simulation. Okay. Built-in scripts. So one of the things that we offer you is the fact that we do a lot of scripting for you. So this is why you don't need a lot of coding experience. For if you just want a probability script for an OR, you would just select that and you'd say, well, what's my probability for the yes branch and what's my probability for the no branch? You'd put those numbers in and you're good to go. You just hit submit, boom, it'll automatically do that every time, okay? Now, if you don't, I mean, so when you hit that submit, what it's done is it's created the code on the right underneath it. So if you selected that OR probability again, you have an opportunity to look at the script. And so that would then give you this view on the right, which is the script that was generated for you on it. And of course, you can go in and edit that script. And again, it's fairly easy to understand. If you're writing one from scratch, we do have stubs for you. So there's an on-end, on-start, and a prompt script option are the three that we have as the main method types for the functions for the scripting. So I think that hopefully that's fairly simple, and for most of the time, that's what you'll probably want to do and use. Okay, as you get into more complex systems, and particularly as you get more lower level in the fidelity higher fidelity in the model, you go deeper into it, then you're maybe doing a lot more scripting, and so that's when this becomes helpful to know. So we actually have created a new scripting guide that's available with an example project and has many different examples through it. It starts out explaining the simple syntax of JavaScript and what we use for that. And so that's a nice part of it. And again, there are plenty of books on this. There's plenty of detail other places. We didn't try to overwhelm that in this scripting guide. We assume you have some experience or some knowledge of this kind of programming. And then on the right is where you might want to use it. For example, when we have this example in this guide of where I've got two ORs there on the right. If you look at the two branches, so asset one and asset two, the thing is that asset two is going to react on what asset one's decision was. So we put a trigger between the two ORs so that the bottom one can't execute before the top one does. Okay, and so when the top one makes that decision, then they can react to the decision in parallel with the development going on. So it'll happen pretty quickly as you go through. But to coordinate that, I have to know, well, what that decision was, right? Asset two has to know what that decision was, and for to pick the right branch, the yes reaction branch or the no reaction branch, right? Because if the guy said yes, asset one says yes, then I want to go down the yes reaction branch. But if I just do probabilities, it will randomly pick one and it would go down the wrong branch and you wouldn't have what you were trying to do. And that might cause you other problems, particularly if you're doing IOs between them. So I might do an IO between P2 and N2 or something, or on those lines. And so I would want to make sure that I went down the same path at the same time. So it's a fairly simple script. Again, you can see it here and you can copy and paste it from the sample project we have. So you can put those in there that way and see how that works. And don't worry about that long number in there. That's automatically put in by using the basic scripts. Usually what I'll start with, because I don't want to have to remember a lot of things, and that first one is a probability script. And so I just use the probability script to get that. And so then I can go through and just add the things I need to add. So I create a global called decision, and decision then value gets set to either true or false depending upon which path it chose in the random pick on the first one. So then when I go to the second one, I go grab that global, and then use that true or false to decide which path to go on. And again, I started with that probability here, and I just stripped out the probability things in it and just put that decision instead. So, I mean, it's minutes to create these kinds of scripts for yourself as you go through and do this kind of work because of the pre-built scripts we provided. By the way, if you are just writing one of these from scratch, don't worry about the long number. It just needs the branch name. It'll handle it just fine. Okay. Okay, so last but not least, Matlab was actually my last, almost last main topic was talking about our co-simulation capabilities with Matlab and STK. So STK, which is is an ANSYS product now. AGI was bought fairly recently, last year or two, by ANSYS, and so STK is part of their pantheon of tools, and it's very quite an amazing set of tools. Anyway, so in it, we've created special APIs so that we can go directly to those tools. And since they're both really desktop tools, we had to create a web service for this. And so we've done that, Java Web Service, JWS, to do this. And so we've built those specifically out for these two tools, but we could extend it and expand it to other tools if you're interested. If there's specific things you'd like to see done. We just have access to so many tools, and so we're using the ones we have. So anyway, for Matlab, it's fairly simple. There's a simple post and a simple get. Okay, so I post the information to Matlab. It does its calculations and then feeds me back the get. So I have the get information available to me, and then I use that information to make decisions or to do other things within the code. On the right, for STK has a lot more things it can do. And so you're not just passing a simple value back and forth. So we have actually a whole set of APIs for STK. And so that's a lot more complex. And like I say, that could be a seminar by itself, but I wanted you to at least be aware that they are available, and we'll be glad to help you get started with that anytime. Okay, so bottom line is making sure our models work. Both discrete event and Monte-Carlo, I've come to believe are essential. I don't know how, in fact, I'm not sure how I did it without Monte-Carlo before. Actually, I do remember it took us 2 days to do that with another tool that had just a discrete event simulator, and it was painful to take all the information from multiple runs and curate that and create this kind of distributions and things we get in InnoSlate automatically. So this can really help you, though, drive those timelines and other performance factors you need. So it's not just verifying that the model works, in other words, that my logic is correct. You can actually start deriving those timelines and do some predictive analysis. Ideally, you will then go back through as you have real hard software, real activities going on, and you will use the timing from that to help calibrate this model and make sure you have the right times, because you're going to guess it at the beginning, right? And you should put your best engineering judgment, we call it, right? and use that as part of this to start that initial analysis. But yeah, you want to bring it into reality as soon as you can. Okay, so hopefully I know that's pretty fast, but I wanted to spend time actually going into the tool and showing it to you directly there rather than spending all this time in PowerPoint, which I think the last time we ended up talking mostly in PowerPoint, it seemed like. Okay, so here's a dashboard of one of the models. We have projects that we use. This is one I use a lot. It's based on FireSat is a model that was based on the SMAD series and introduced to us in the aerospace community as a satellite that would do fire detection. Okay, so with that context. So if I want to go to the action diagram for this. So let's see, I've actually got it right here. on my dashboard. I've got a widget here that shows this particular diagram. So I just can come scroll down to that and then select it, and it's going to make me sign in, of course, because I was talking too long. Good cybersecurity. We want to practice. We want to make sure we do that. Anyway, so here's that model. So let me walk you through it a little bit. So we're launching a payload to orbit. If I go decompose that, I see the different stages it goes through: the launching to space, deploying into orbit, performing space commissioning operations, maneuver to orbit, and then perform payload commissioning operations. Okay, so again, you saw I just clicked that decompose button, and it popped me right here to it. Now I can go back to the parent by open parent, or hit the back button. Either one, it's fine. Again, if you want to see that drag and drop in action, let's just show you one as an example. So here, you see, I don't know if you can see it or not, but the line is turning green. As soon as the line turns green, I can drop it, and it'll put it right there, and it'll move everything else down. And then if I decide I don't want that, all I have to do is come back here and undo last action. Okay, and again, very simple, very clean, very easy to use. Just a little more mechanics, by the way. The lines, if you don't like the lines, the way they look, you can move them around. Okay, there's just a lot of things you can do with that. So it'll help you, again, make it the way you want it to look too. That's important. You see here is an example of optional going on. If I wanted to turn that into a trigger, all I have to do is go to it and hover over, and I could pick trigger. That would make it a trigger. I don't want that, so I'm going to go back to make it optional. Okay, so let's dig down a little deeper into this model so you can see a little bit more. So let's go down to the next level here, which is perform normal operations. So if you notice this high level thing, it's continue operations. I have to decide if I'm going to go normal or contingency, and then I'm going to transmit updates to the ground periodically. Okay, that's a loop that's going on over time. And then, of course, at the end of this, good systems engineering says if I'm done, I'm going to dispose of it. Of course, if this is a long-term constellation, maybe that doesn't happen for decades. That's okay. This is the loop operational loop that you'd be in during that time. So let's go look at normal ops a little bit more deeply. Here's that. In fact, here's that diagram that shows you that message, and here's that 911 message. And if I want to see the conduit that's associated with it, I go to relationships and go down to transferred by, and there's the conduit. And if you want to see the words, because it's too small, you can always move the sidebar here. It does collapse down to only a certain level, or you can completely get rid of it. Okay, so you have to just click in this little arrow here. That's, again, a little bit of mechanics, but sometimes that's helpful to people. Okay, so again, you'll see the process. Fire exists, yes, and so I need to be able to detect the wildfire before I really do anything. So it's up there flying around. I've got to see that there's a wildfire, so I'm going to see if there's a fire happening, and then it will go through and detect the emissions. And navigation signals are happening simultaneously. So right now, the way this model reads is I'm going to execute this top one, this wild detect fires, and then I'm also going to go here and be sending navigation signals. Now, this action cannot execute till it receives both those triggers, okay? And then once it does that, then it can go send the 911 message and loop around in here. So, and then sends warnings, which then sends to our task force. And then we go down and respond to the fire. And so that has initializing the response teams, fighting the fire, okay? And then, of course, once you've extinguished the forest fire, you report the fire damage. Okay, so let me dig one more deep into here. By the way, this is the first time we see the resource pop up. So there's the forest fire, so we're treating it as a resource. You'll see why in a minute as I go down in here. So I have two resources, the water resource, okay, and I have the forest fire. Again, this is a very simple model. And so the idea here is that once as the water is starting to extinguish the fire, you'll see the fire go down. But at some point, the water is going to run low. And again, this is a place I've used a script, one of our built-in scripts, our resource script. And so if it gets below 4,000 units, again, I don't know what the unit, whether it's gallons or what the units are here, but that's okay. It doesn't matter. Just pick this, keep a common set of units. And it will go down that yes branch, and then it will refill the tank, which makes sense. And that's going to cause a delay. Of course, while that delay is happening, the fire starts building back up. So it's one of those things where you're playing whack-a-mole a little bit. But anyway, so here's that OR resource I mentioned. So if I want to look at the actual script for it, again, the OR has probability or a resource script is available to it. The loop has iteration, probability, and resource, so it has 3 for it. Okay, but if I've submitted a script and I've created one, I can go see the actual script itself that got generated, and here it is. So it's very, very simple. It's going and looking for the amount of that global ID, and again, you get the global IDs off the metadata tab for any entity. I'll show you where that is again in a second. So I pull that out, and that's my resource that I'm looking for, which is the water resource. And then again, if it falls below that 4,000, then I want to go down the yes branch. Otherwise, I'm going to keep going down the no branch. So let me show you that about where that global ID is. So here's that global ID. Now, by the way, there are other things I could have used. I could have used a name. I could have used a bunch of other things to grab it. Just global ID is one of those things that's very unique and specific. So now I'm absolutely certain I'm going to get that resource, not something else. So again, that gets into a little bit of the coding side of it. But again, if you noticed, you didn't have to do anything with that script, right? That script was auto-generated from the user interface that we showed you before. So don't worry about that aspect of it. If you say, oh, I don't really want to remember all this stuff and I don't want to get into the coding, not a problem. Just go in here, put these in. You have lots of different operations that are available. You know, it should help you build what you need to build in terms of a normal logical script. Again, if you need to modify it, you can go in there and modify it. You could add print statements, which will print out to the console, things like that. So feel free to do what you need to do with it. Okay, so we got that. So this is the model, and so now let's take a look at what it looks like in simulation. So let me go back up, and again, I can just go back or go up. Do it that way. Parent. There we go. Okay, so here's my model. I'm at the top now of the model. So now I want to execute it. Oh gosh, what am I going to do? I have to do the simulation. Oh, wait a minute, there's a button up there that says simulate. Here we go. And you click on it and it has discrete event or Monte-Carlo. Okay, my life is pretty simple. Great. I can just select that discrete event. And we have, by the way, a black mode and a white and a light mode, a light and dark mode here. So you can choose that. By the way, this is that 3D diagram of the whole model. So if you want to see what those things are, you just can click on one of the objects and see that information about it right there. Sidebar. See that. Let's be something different. Okay. So again, very easy to navigate it. If I hover over it, I also see the name, okay, of the action. Okay. By the way, the model can get so big that you run out of pixels here. So right now this is defaulted available to you. We're going to make it so it's not, because we're running into a lot of models lately that are so big it does break it. And so again, that's just a limitation of the memory size that's available in the browser. Browsers are limited to 2 gigabytes. And so it's just, that's where we are today. Hopefully some of the newer browsers evolution of the browsers will bring us the ability to get more, take more memory and do more. This is actually executing in the memory of your computer. So this is all written in JavaScript, and so that's why that's the case. So we also have a classic mode. There's actually, if you want to see that, it has some different Gantt charts and things like that. It's not quite as pretty, but it's a little bit lighter in terms of the memory usage. So again, that's another option for you. You have all kinds of things you can add. Pick different types of things you want to see. I think I've got a number of these on here already, so I don't think I need to add them. But you can see, so if you need to add some cost over time, I'm pretty sure I have cost over time. I don't have cost over time. And then you can select what you want to see. And I really just want to see total over time. I don't have to see individual. If I had ones that were changing a lot in terms of their numbers, their cost numbers, I would want to select one of those other options. But total is what I really care about. And then you can pick the color. So if you want to pick green, because gosh, it's money. So let's do mean. And just set that. So there's cost over time. So there's actually two of these cost over time. You have multiples of these, because now what you can do is you select which one you want. Okay, so I believe this one was set up for just cost. Yeah, as a blue one. So we'll just leave it there. I have both of them there. Okay, so that shows you how to add a dashboard widget. And then, of course, one of the things that should be on here is the console, and I think the console's here somewhere. So I have to find the console. Okay. So anyway, and then help, and of course settings. So settings are here where you can set the mode, the display mode, light or dark. Here's the dark. It's too dark usually for this kind of presentation, so that's why I usually use light as my default. There's a calendar mode. So if you are using this simulator for project planning, you can actually have a calendar mode where it's going to look at things at your times, particularly your start times of actions, and determine whether it can execute that action or not. If it's not in its start time, it's not going to be able to do that. You can set your speed, so you can adjust the speed how you want to. You can go real time or slower than real time. So if you've got processes you're trying to model that are very short in duration, you can go down to a millisecond. Okay, but it's as low as it gets because that's the clock speed, and that's what we're using as the clock as our time thing. So yeah, milliseconds to your lowest time. If you're trying to model something that's even lower in time than milliseconds, then my suggestion is put it on a scale. You have the ability to automate or do prompt with no script. So if, let's say you didn't add a script and you just had decision points, it'll prompt you for that what branches to go down. So it'll help you. Again, you can use this then for tabletop exercises. So that's another thing that we built into it. There's normal and debug mode. So what debug mode is, starts you in the step mode. So you can step then through the discrete event simulation step by step rather than having it execute in time. Hours per year, that's used again if you're in calendar mode and you're trying to do something for people resources that are then expending time, and so it limits their hours, and so it's used to help you create a more correct number. Random seed, for the most part, you won't use that unless you have a problem in Monte Carlo. It will automatically bring you back into here and put the random seed there. The use of that is if you want to keep coming back to that one, you fix something and try it again, you can copy the random seed, put it on a little clipboard or something, and then use that for it over and over. So that will help you really debug problems. In fact, I call the discrete event simulator my debugger for my Monte Carlo now. Matlab integration URL, that's here. So this is for us to be able to connect into Matlab. We need to know where it is. And again, it's going to be on your desktop, or it's going to be something else that you have available to you that way. By the way, this feature is only available in our enterprise version. But you can set up the enterprise version on the cloud. as well. So that's interesting. There's the console. And then once you're happy with it, you save settings. Okay. And of course, there's a default settings tab as well. Okay. By the way, another thing that's in here is the global tracker. So this will actually track your globals, and you'll be able to see how those global variables are used. Okay. So that's this thing. Yeah, this was yeah. I literally have everything up here, so it's quite a complex set of information that's here. So maybe I will get rid of this one because I don't need it twice. So put it that way. What I can do, since I decided I want that in green, I just can come over here and just change it here to green. So now that'll be a green line. Again, you can move these up. They resize. It's another kind of thing that is new with the tool. You can resize it as you need to. Make it as big or as little as almost as little as you can. There you go. It's as small as it goes. You bring all these up. Asset utilization over time. There's the global tracker and console. And you just bring them up. And if that's something you want to see, particularly the console is something you might want to expand, be able to see more out of. If I'm getting really into scripting, I do a lot of writing to it to simulate particularly maybe an operator interaction, and I could see then what the operator would see, so I could use it like my display panel for the operator. So again, just textual display, but still it's pretty nice. Okay, so let's go ahead. We got it all set. We're happy. I'm going to save those settings so I don't have to do that again. And play. So you can see it stepping through. You see it, the blue, and it turns green. That's when it's green, it's executing. And it's building up the Gantt chart. And you see I'm building my forest fires, starting to build to a level that it can be detected. And there's the receiving 911, so we're going to see that. I see that up here. So now we'll see them go through that process. And now we're in the response process. So here we go. So now we're going to start putting the water on the fire. And so there's that going back and forth. And of course, as the fire builds, it starts going down, drops, and then it drops below a certain level. There's some refilling of tanks and refilling of things. And it'll go through this process. So this can take a while. You scroll down, see some of the other things moving. You see here's my cost changing over time, my pie breakdown chart. I have a lot of stuff on this, so I hope I have enough memory. Here's some example of the simulation. Global identified here. So anyway, so you can kind of see what's going on here with it. If you want to speed it up, you can do that. And this particular model can take a while, many, many days. So again, it is dependent on all the information that's happening here. You can see now it's went to a spinner because it wanted to speed up. And so it can't render all that information fast enough, so it'll just spin and go. And you can see now it's gone a lot faster. And when there's that big delay, you see the fire building back up here on the bottom right. So that's the fire, is the red, and the water is blue. Makes sense, right? For color schemes. So you see we're already up to almost a month. This must be California wildfire season. So yeah, this particular model is long. Okay. Finally finish up here for me. It's like I finally put out the fire completely. And It's going to take a little bit of time. There we go. So there's the final. Again, I can look at my Gantt chart, see all the things that happened with it. We see yellow, that means it's waiting. There's a wait state. There are dependency lines here, so it is a Gantt chart kind of form. You can do an awful lot with this chart. This has a lot of information in it. So if I scroll down, I can see some of the other things as well. So anyway, that's the discrete event. So let's go back. Just refresh the browser here. There we go. So let me go back up to the top again. I'm not sure why I ended up down here, but I did. Okay. So here I'm going to talk. So let me run the Monte Carlo. That'll actually go a little faster because I'm not rendering all that information. That's what takes the time. It's not that it takes long to compute. So if I just hit play, and I have this set for 1,000 iterations. So again, you can do that in the setup, and I'll show you that in a second. But so I just kick that off, and it's running at 1,000 times. And again, I've got a fairly good machine here it's running on. It's a MacBook Pro. And so you can see now these distributions. So the time distributions show me that it went from about 12 days to almost 2.5 months. So this particular one ran that long. So and that's not unreasonable for the, again, in California's fire season. Unfortunately, some of the big fires take a long time to put out. And this again goes as low as $100,000 and up to 1.2 million. So so again, you can see those distributions. Again, if you're trying to understand your risk, again, if you think that I'm going to budget for my fire season and I'm going to budget $800,000. Well, I run the risk that I'm going to run into fires that are going to be over that cost, and so per fire. And so again, hopefully I run into enough of these that it's not a problem, and I budgeted sufficiently for that season. So again, hopefully it helps you see that. Again, the heat maps here, I'm sorry, tree maps. You can see how long it's taken and what. Respond to the fire was where most of the time is being taken. And perform contingency operations, though, is where the cost is. So that's if you're having to move your spacecraft or doing something else with your spacecraft that might take a very big chunk of money. So hopefully everybody can see. By the way, there are project exports for these. So if you are using it for project planning, you can do it. You can do that. If you want to do your settings here, again, this is where you set your iterations, hours per year, max cores. So you can actually limit the cores that you use for it. And again, Matlab integration if you're doing Matlab. So that's really all I had to talk about today. I think I hit all the key stuff in it. So let's just hit the summary slides, and then we can have questions if any are available. So key is predict the future. Use a well-calibrated simulation to do that, okay? Again, it really does matter what we do and how we do it. So we're using this to help justify sometimes billions of dollars on projects. And so it's important to have accurate analysis, and give that high quality analysis can really save the project. You can show where things are going to happen or where you might have problems, and you kind of do that predictive side of things to avoid those problems in the future. It can keep your program from being canceled, okay, or obsolete before it's time. High quality simulations, again, you need a discrete event in Monte Carlo simulator. I don't know how, frankly, I even operated without the Monte Carlo for so many years. And then if you're really worried about operational problems, look at Zapatra. It's a really good opportunity. Anyway, so we have time for questions. Elizabeth, do we have any from the group?
Thank you, Dr. Dam. We do have several questions. If you haven't had a chance, please use the panel on the right to ask your questions. Our very first question is, where can I get the scripting guide?
Oh yes. So we're hoping posting that very soon on the website, but if you want it sooner, just email support. They have a copy and they can send it to you.
Thank you. And then how long does InnoSlate Monte Carlo simulator take to run? What about 5,000 iterations?
Wow. Okay. Again, it's dependent on your machine and how many cores you have and how much memory you have, those kinds of things. So it can take a little while for 5,000. I've done up to 10,000. It takes a few minutes. You saw how fast 1,000 was. So it is dependent on your model size.
All right, thank you. And can you explain more about the random seed?
Oh, sure. So we just use a random generator for the seed, and then so use that to do the Monte Carlo kind of probabilities. So it's just a basic thing. So so those seeds get created every time you run a Monte Carlo run, and so that represents one of the discrete event instances. And so if you then have that seed, you can always make sure you go back to that one if you're trying to debug the diagram and figure out where the problems are.
Thank you. Our next question, is the fire extinguished when the blue and red lines interest?
So the blue and red lines were set up so that you see the water and then the red is the fire. So when the fire goes out, it's all the way to the bottom and it goes completely out. That's when it stops. And so I think that's the way this particular simulation is set up. But again, you can make it do whatever you need it to do. So.
Thank you. We have more of a comment than a question, but I wanted to read it out loud. Thank you very much for the overview and demonstration. Very informative. Unfortunately, I have to leave the demo now. I would be interested in discussing the feasibility of interfacing with XtendSim and some combat models, e.g. MANA.
So actually, we have done some work looking at things like XtendSim and other ones. We have a CSV also import-export capability that we can use to take other simulation data. And so there's some other some other tricks we have with that. But of course, to set up the actual APIs and things like that is a fair amount of work, and we're happy to do that for somebody. But we probably want to talk to you about money. So.
And this is the last question that we have so far. So if you do want to ask a question, please do so soon. Where do you set the rate of consuming the resource?
Oh yeah, so I didn't show you that, but it's actually in the action itself. So let me get back to the model. And the easiest way to do is go down to the resource. Let me do that first. And so here, I can click on it, and I see all the relationships. It's consumed by these various actions. So and let me make that bigger so you can see them. So we have these different firefighting teams. The way that you fight a fire is you come at it from all directions and contain it, and then put it out that way. And so extinguish the forest fire is the last one of that set. So that's the final one here that's associated with. And the amount it is here that it's doing it. So we're using normal distributions for this. So you can see those values there. So you can set that amount here. So that's how you set the amount consumed. Great question. Thank you. And similarly, by the way, we produced. So here's the one that produces the fire and spreading the fire. And so these are different distributions we're using for that. I'm not sure how much scientific analysis there was for this. We did have one of our systems engineers who had spent summers fighting forest fires actually helped develop this model. So I believe his numbers are fairly realistic.
That's all the questions that we have right now. Thank you everyone for your questions and your attendance. Just a couple of little announcements before we end this webinar. As a reminder, we will be following up with you very soon to send you a link to the recording and the presentation slide deck. We would also like to invite you to our next webinar, part 3 of the How to MBSE series, How to Perform Configuration Management, on April 13th, 11 o'clock a.m. Eastern. So be sure to check your email for the invitation. We'd also like to encourage you to visit our website, check out our books and our blogs, as well as connect with us on social media. That concludes today's presentation. Thank you again for your attendance, and we hope to see you again at our next webinar. Please enjoy the rest of your day.